Hello everyone and welcome to another What's in a Codebase video. So I've been thinking which codebase to pick up next, and I had llm.c and Git in my mind. And based on the replies of this Twitter post, follow me on Twitter by the way, most people wanted me to pick up Git. So that's what we're going to be doing. Yeah, look at Git, and Git hopefully does not need any introduction. So let's get started. Now, like I've already told in previous What's in a Codebase videos, before jumping into a very large code base or any large software, right, you want to be able to understand at a high level what it does. And thankfully I don't have to explain to you what Git does. It's a version control system, everybody uses it. Git push, Git commit, Git uh, add, whatever, right? um, yeah, however, just knowing that is not enough, right? Having a good high level understanding of the architecture is also usually pretty useful. And I would not really recommend jumping into the code base without that, but depending on your task, it can be done. Now, because I'm so good at programming, already have a high level understanding of Git thanks to this book called the Git book, right? This is the link. Oh, come on. This has a chapter called Git internals, which teaches you the internal architecture, not exactly the architecture, but like what are the basic building blocks of Git. I think it's pretty useful. And yeah, so do give this a read if you have time. And also, obviously, before jumping into any code base, you want to look at README, code of conduct, uh, like if you want to join the community, contributing.md, how you can contribute, license, it is GPL2, and security. Okay, so from somewhere around here, I found how to do your first contribution. This is also a good read, and I would recommend reading this before the Git book or anything like that, because this will teach you how to do basic changes in that. The main thing I want to look at is how to build the project. So I did a Git clone and I opened it in CLine. Amazing IDE, obviously it detected makefile and properly indexed everything. So if I randomly go into some file, right, I was testing that only, I can navigate. This is like unforeseen in a C project, in my opinion. Now, personally, I've never really professionally worked at C. Uh, I've not even professionally worked at C++, but I've worked a lot in C++, so I would be more confident in that. But C, I somewhat understand, so it should be fine. Not a problem. Anyhow, as I was saying, C line is amazing, and I opened it there, and I have made the project using make, just so that caching for build is done if we need to do that. So pretty big prologue, monologue, whatever, right? Let's now jump into the code base. I will explain to you the high level architecture and everything as we go along. I have also forgotten how like all this is. After learning this, I made a project. Oh, come on, bro, come on. I made a Git like VCS implementation in Haskell. So naturally, I would have a bit more understanding of Git than someone who has never done something like that. So yeah, doing all these things are obviously pretty helpful indirectly, somewhat directly, but more or less, the best thing you can do is jump into the code base. That's what we're going to be doing. Okay, so this is the README. I'll just close everything. Okay, so so the first thing I do is I look at the structure of this folders. Now, some people don't like looking at the structure of the folders. I don't know how they figure anything out about the grouping, but I like that. So we have binary wrappers, we have block SHA-1, we have some built-ins which look like the actual commands. We have CI, which is probably something we won't be needing. So in every directory, you can many times find a README, which is also useful. Here we don't have, but that's fine. This looks like just built-in tooling around, right? So CI we can ignore. Compiler tricks, this can be interesting. Contribution, how you can contribute, I guess, yeah. Okay, now we have CMake, interesting. Wait, what is contrib? Define. Hmm. And this looks like auxiliary tooling support, honestly. This can go. So yeah, this is what it looks to me. Is that the main code is here only. Like you see, there's a lot of files and lot of executables as well. And then I'm still scrolling. Okay, and then you get like these things are probably just adapters for different things or very self-contained things, and this is the main code. Okay, so just a cursory look of the structure, right? Now let's see. Now usually when you are jumping in a code base, you have a task at hand, right? And that helps because you're able to abstract out other things, abstract as in like ignore other things and look at that. But because we are trying to explore this code base, we're not gonna isolate ourselves like that. So I'm just trying to see where can I start. This is where do I start? Let's see. Is there a main file? Of course, there is for tests. I don't want to look at tests. So let's look at makefile. So what does makefile do? Makefile makes the binary from the source code. Let's have a look. Let's have a look. So much comments. Oh, come on, man. Stop. Wait, do we have a all? No. Okay. So this is completely out of my expertise. I'm not an expert in anything though. But makefile, see, none of this I know. So bear with me, right, as I stumble my way across this code base. What a heavy beast in itself, honestly. Mm-hmm. Do we have Git as a library also? Wow, that's nice. Let's have a look at this. What do they get? Binary wrappers. Okay. So what is in binary wrappers? We have okay, is this like a wrapper for the Git library? Let's see. So what they have done, right? They have add a new command, psuh, and built-in. Okay, let's have a look at built-in. Okay, so this looks like it has all the commands, right? For example, rebase is a command. I know that. Why do they have object file in the source code? I don't know, man. See, people. Do they have main? Where's main, by the way? Uh, oh, we have a common main. We have base 85.c credential. Hmm. We have a main.c in unit. That's not what I want to look at. Hmm. Okay, so this is the common. Okay, looks like this is what is executed. So based on that, we, okay, in git.c, we run whichever command we want to look at, and handle options. So it looks to be like this is the entry point. I don't know. Init git. So what do we do in init? Trace initialization, sanitize stdfds. What is that? Always open fd012 to avoid clobbering files in die. It also avoids messing up when the pipes are duped onto. Okay, let's have a look at this. Okay, so I I know all these words, but I'm forgetting what all of this means. It also avoids messing up when the pipes are due. Okay, what is what does pipe dupe means exactly? Uh, Come on, what the heck? Unix pipe dupe. Yeah, they're talking about dupe system call. Uh, wait, what does Unix? Let's have a look. Unix gets a copy of the given file descriptor. Okay. Okay, okay. So if some, I think it can be a soft link or hard link. Yeah, dupe and dupe too. So we're always opening. Okay, it's probably something related to C, right? We don't, I mean Unix. We don't have to worry too much about it. Resolve the executable directory. Initialize repository. Let's have a look at this. Which file is this? Repository.c. So objects, remote state, allocate array. Okay. So the repository. So these are globals. Nice. Okay, so that's one thing. So this is the repository struct in this file, right? So in C++, if you want to create a repository object, what you would do is repository repository, and then let's say the repo. But in C you have to do struct. So that's all. You don't have to worry too much about it. So static struct the repo, and this is that. So we initialize the repository when we are initializing Git, which ODB new. What does that mean? Object database new. Okay, so it's creating an object database for this repository. So xmalloc. Okay, this will be interesting. Now we're picking up base, maybe, I don't know. So object database, what is that? Object database encapsulates access to objects in a repository. It manages one or more sources that are, okay. So quickly, right, what is an object? Git objects, right? So everything, okay, I have also forgotten. It is a content addressable file system. Okay, maybe if I look at my own code, I might figure that out quicker. Oh, I wrote it in Haskell. I won't understand anything. Rip. Oh, okay. So what an object is it can be anything really. Uh, I think it can be a commit, it can be a file, it can be whatever you like. Okay. And the way it is stored is you create a SHA-1 hash of that object data, right? And then you store it like this. The first two are name. So this is the SHA hash. The slash is just you create a directory out of the first two letters. So git objects g6 this. So I believe this object database is an encapsulation of this database architecture, whatever, right? So we have a repository that owns this database, sets all the. Uh, I just want to say this looks so clean, right? Like I've looked at a lot of C++ code bases, not a lot, but I've looked at them, and they look messy. This looks pretty neat. Like I mean, it's a double pointer if that's neat to you, but okay. So we have a source, set all the object directories. The main directory is the first, cannot be null. Subsequent directories are alternatives. Okay. Now I have a slight neck pain. Sorry about that. What is an ODB source? ODB source, actual objects. It does encapsulates the logic to read and write. Oh, so I never knew this, that we can have alternate object. Oh, let me actually increase the size. Oh, come on. What am I doing? I don't know how to use this, bro. Just give me a moment, okay? I'll figure this out. Okay, I figured it out. So ODB source, it has a next. Okay, it's a linked list. What owns this? Used to store the results of the directory calls. So okay, odb.h, and then we'll have odb.c. All right. Yeah. So this is one thing I'm not a very big fan of, but I think LSP support can help with it. But basically, if you think about, right, this, this, all these are just methods for this object database type. But because C does not have methods, you have to do it like this. But okay, whatever. Who cares? Maybe actually there is support for that. Let's check. If I do o dot, no, this is that. Let me just go here and look at some. Mhm. Yeah, it automatically does that. So ODB restore primary source, right? ODB. Okay, so it does that. So LSP already has that support. It's fine. Doesn't even matter then. So we create a. Okay, so in ODB new, we first of all malloc the size of this O, which is this. So whatever the size is required for this, we are telling it to malloc that. What? Oh, okay. I feel like this Vim idea Vim is somewhat different in different editors. Let's have a look at xmalloc. We don't know what that is. So xmalloc, what does this do? It returns do xmalloc. Awesome. Then it is a gentle parameter. Oh, so return value if memory limit check, size if limit. Oh, so we can set the git allocation limit. Awesome. I never knew this. Oh, come on. No, I copied it in the Vim buffer, not that buffer. See, these kind of things you would know if you already work with the code base. So we can, so what xmalloc does is it goes and so this is I think just a wrapper over parsing environment variable. Yes, so it's getting an environment as a long, so unsigned long. All it's doing is it's getting the environment. This is a standard library function. Then it's parsing long. So this is another thing in C, because C does not have namespaces. Uh, think about it, right? This this name parse long. This is probably very common. So what libraries do is they prefix every function with library name underscore or whatever namespace they want it to be in. Yeah, obviously namespaces would be better. In this thing, I think namespaces are objectively better unless they have some weird caveat that I don't know about. They also have a die function. Awesome. Like, who doesn't want to die, right? If die is recursing, oh, wow. What the heck? Okay. Recursion detected in die handler. So probably what this is doing, right? This is just a guess, but when you are not able to do something, you are doing die, which is like a panic in Go or panic in Rust. I think Rust has panic, right? Yeah, Rust has panic. Panic or panic and this class. What is that? Mm-hmm. I think terminate, std terminate or something like that. So it's more like it's a graceful terminate where you want to run a bunch of handlers before dying. So what you do is if you want to die, what is k? So you say you die and then you run the routine that is required for die. So I don't know what va is. Va is probably variable argument list params. I don't know where it is being filled. Va start, we can look at that, but whatever, right? However we are getting parameters, we run some die routine and then we end that. So die routine is die built in, which get die message routine and then die message function uh, is just that, and then we exit with exit code 128. Come on, not ext, exit code. I don't know how to type. Okay. I think this just means what? Okay. So I'm pretty sure that's what they want to do. And now what can happen is die could be recursing too many times. So how we check that is we have a static variable, are we dying? So when we check die is recursing built in, we check are we dying. Recursion limit is this much. Hmm. Okay, so you want it to be greater than the number of threads. Then you just increment it. So every time die is called, you just increment die, and if it exceeds a certain limit, which is 1024, you say recursion detected in die handler exit 128. Now I'm like die routine, I don't get too much point of this. I guess maybe, oh, okay, so we will look at this. Actually, I'm curious about that, but I'm not very sure why we have a die, why we have this indirection, why not directly called die built in. Probably the reason would be so that we can switch the die routine from the die built in. The die built in just reports, okay, die message routine, die message built in, traces, reports, whatever, right? So yeah, we just call that. Now the thing is, okay, I think hmm, report f. Hmm. Anyways, so I think, yeah, I think that's the main idea, that we can change the die routine. Now I don't know how it is changed, but there's another important and fun thing about this die function. Look at this return type. It says no return pointer. What this means is when you go to this pointer, when you go to and not go to this pointer, but execute the function at this pointer. Pretty sure that's what it means. I'm no C expert, but it never returns. So it's a diverging function, I think. Yeah, diverging functions never return. In Rust, you specify them using an exclamation mark. So in Rust, you specify the return types, right? So let's say you write a function foo that never returns. You say this because you know it will never return. I mean, the compiler will also check, but whatever. So let's have a look at this. The definition of no return pointer. So it just says um, attribute no return. So this is an attribute to let the compiler know that this function will never return. Now I went to this definition because this was true. So this is a compile time definition, right? So the way this works is, if you look at this entire block of space, if we are using HPCCC, I don't know what this is, probably some architecture, right? Then you specify no return pointer as nothing and no return as this attribute. If it is GNUC, which is the compiler I'm using with the makefile configured, right? And we have not defined this, then no return and no return pointer are defined like this. So that what this means is, when you compile, all right. So when I compile this, oh, this does not work. So when I compile this, this would be what it looks like. Now, this line of code cannot be compiled by, let's say, Microsoft Visual Studio, Microsoft Visual C++, Microsoft Visual C, if that is a thing. But it can be compiled by GNU-C, so it will work. So that's why we have these as if defs. So if GNU-C, then do that. If Microsoft, then you use decal spec, no return. It's called declaration specification, right? Probably that's what it is. You can search it. Let's have a look. Decal spec MSVC. So you can look at it. It's a declaration specification. Extended attribute syntax for specifying storage class information. Okay. So yeah. Now what's the point of this, right? If it never returns, why do you care? The reason you care is because I think the compiler can do optimizations based on that, and you can actually check what's the let's actually open Gemini. What's the point of doing things like return? Yeah, it's mostly about that, and error checking also. So that's how the die is working. Now another thing I'm curious about is, how is the die routine being specified? If we are in DL open is just like dynamic library open, I think. Oh, by the way, so the point is, so right now you might be seeing that die routine never really would recurse, right? Why would it recurse? The reason it can recurse is, you can probably have a different die routine, and if that also calls die because something unexpected happens, then you do a die inside a die, and then that will probably also die if you're like in some very bad state, right? So you will keep dying, and you will never die. So you keep dying but you never die. So that's why you have this. If you look at this, oh, Casey, is this Casey Muratori, the man, the myth, the legend? No, it's somebody else, obviously. I want to look at this. Detect recursion. It is theoretically possible for die handler to get into state. Yeah, So I was why I looked at this is I was curious whether these people. Oh, wait, am I looking at the correct def? I am looking at the correct def. So I was curious if this was an actual bug or they just added it because they figured it can happen. And it looks like it was only a theoretical possibility. They had never really encountered that. For example, if a die handler calls another function which calls die, let's at least detect the situation, inform the user, and call exit. Yeah, that makes complete sense. This was my intuition, just like I explained you guys. And this another thing you can do: annotate, look at what the commit says, and figure stuff from that as well. Anyways, we were at x alloc. So if no limit, so what this is doing is if limit is not set, you get the limit, pass it as unsigned long, and if it's not that, you just say size max is this, which is uint ptr max. So what is this, right? Uint ptr is the size in which you can store a pointer type in that architecture. So that's 64 bit. You can look at this, it's 64 bits. And again, this is true because in my computer, my compiler and everything, this is defined as 64. If LP64, what is LP64? It is, it's probably defined by the compiler, I guess. But if that's the case, then word size is 64. And if word size is 64, uint pointer max is this much. So if size is greater than the limit, then if gentle, then we say attempting to allocate, we return, otherwise we die. And now, who are these people? Why have they not done it like this? Thank you very much. Uh, okay, so this was the memory limit check. After memory limit check, what we do is we do a malloc. So we don't have a custom allocator. We just simply have some bounds checking. So that we can have custom memory limits on the Git allocation system. And then if that fails, then we malloc 1 byte. Why? I don't know. Okay, so basically if malloc fails, I don't get it. Why? So basically if size is 0, then we try to, oh, maybe, I don't know. Let's have a look at this. Why Mr. Torvalds have done this. Uh, so I'm used to having a link here which opens it in GitHub, yeah, because that's how it is in my workplace. But anyways, shrink the Git binary a bit by avoiding unnecessary. So what has he done here? Oh, this looks like he has moved code. Man, it's gonna be fun. I don't know how to go to the correct history like that, but we were here, right? Yes, I don't know how to get the history of a line that has been moved. Probably what I can do is look at this. Wait, no, it doesn't look like it's moved. It looks like it has been created. If not red and not size. Okay, I don't know why this is done. Uh, and that's why we can ask GPT. In some C code base, I see this logic. It doesn't make sense to me. Help. Yeah, so when size is 0, oh, the standard behavior of malloc 0 is it is implementation defined and can vary. It might return a null pointer or it might return a non-null pointer to a block of memory that can't be used. So to make sure it is resilient, regardless of the implementation, you do malloc 1. And see, probably if I search the same thing, right, in Google, I might have found something. Yeah, I would have found this, but chat GPT or like LLMs, right, they help you with these common things so nicely. And if you're still not able to allocate, then do that. And then we also have poison. So if we poison, then we do a mem set return 0xA5 size. And if, wait, so what is xmalloc poison? So have a look, let's have a look at this. So let's go for kit, way to see if you're using. Okay, oh wait, it's doing mem set. I did not realize it's doing mem set. So what it's doing is after allocating, it is filling every byte in that with 0xA5. So what is A5? Like 5 plus 16 times 10, right? Yeah, I think that's what it is. So 165. It's filling it with that, the entire memory space, so that you will know that um, you are using uninitialized memory or not. If you use memory and the, yeah, so if you use that memory and everything is this, then that means you haven't initialized it. You haven't set things to 0 or whatever should be the initial values. So that's a simple wrapper over malloc. Okay, cool. So look at all this debugging stuff. It's all nice, tiny chunk of information. So there was already so much to unpack in just this line of code, and honestly, I'm really enjoying the C code base. Uh, it is written very beautifully. Like if you look at this, it's so beautiful. Like I'm really liking this. I remember I was looking at Kubernetes, right? That was so trash. Like, ah, man, probably just this is the honeymoon phase. So yeah, so after you have malloc, you have to initialize everything to 0, probably because that is the uh, 0 state of object database. And if you don't do this, then and if you're using the malloc poisoning, xmalloc poisoning, you can figure stuff out. So you say repo is repo, initialize the list head object dot pack get mru most recently used cache. Okay, so this is just the, so this is the head to the mru cache that this object database has. It also does a hash map in it, so they're using a custom hash map implementation. In this hash map.h, you can look at it. It's a generic implementation of a hash based key value mapping. Example, mm, I wanted to see if they mention what hashing, not hashing algorithm, but like what the hash map algorithm in general is. Oh, it's this. No, no, this is for hashing the function. Yeah, it's for hashing the key, not like what the hash map algorithm is. Follower, no, yeah, it's a hash function. Okay, but whatever. We can look at the hash map implementation, but that would be very DSA like, and I'm not really a big fan of that. I want to look at interesting things, man. So we're gonna ignore hash map. We also initialize the pthread mutex and all that. So if you think about it, it's just the it's just like the constructor of um, this type, right? It's just that you do not define it as part of this. It's just ODP new, and it's no problem honestly. It's probably just a convention that underscore new type name underscore new is the allocator for that. I mean initialize a constructor. So okay, ODP new. This is pretty trivial. Remote state. What is remote state? Oh, we have a catalog. Okay, this will be interesting. So whenever I'm looking at C like code bases, C, C++, I don't look too much. So I am always interested in the allocations. So we have a remote state, which probably tells the state of the remote repository. And this looks like that. we have a array of pointers to for this remote, which is all this information about the remote entry, alloc, nr, whatever, probably just some things they need for the processing, right? So we have a calloc array. What is that? It's a xcalloc. What is xcalloc? It's in wrapper.h. Wait a minute, how did that link in? Oh, because it's wrapper.c. I'm stupid. So what the xcalloc does is, so first of all, let's have a look at, we know what malloc is. Let's have a look at what calloc is. Okay, whatever, man. Let's just ask ChatGPT. I saw different answers. What is calloc? Ah, man. Be concise. What is calloc? Contiguous allocation. Isn't that malloc? Oh, probably is. Okay, calloc initializes all the bytes in the memory to 0. So xcalloc also looks the same. We have a memory limit check. We do a calloc. If we did not have to do, if we had to do 0 byte allocation, we do a calloc with size 1 to handle all architectures, and only if we fail, right? Uh, Otherwise, out of memory, die, whatever. And xcalloc, the calloc array is just a wrapper over xcalloc. So we create an array of this, right? Of size 1. So this is the remote state array. Hash map init. We initialize the hash maps, everything we needed to use this remote state struct. After this remote state struct is supposed to be usable. Then we have, yeah, we're doing a lot of initialization. Similarly, alloc array, I think it should be xmalloc. Yeah, cool. Then, so we were just looking at git init, right? And it's initializing everything. So much initialization to be done. Attribute start or attr start. All it does is global attr hash map. Okay, so it's just some global attribute function type or container, right? Initialization for that. Trace to initialize. I don't know what this is. Trace to. It's for tracing for it's instrumentation API, but I'm curious how it is like groups initialize, emit command control message, emit child start stop message, exec thread def. So I believe the way this tracing works is you have to call these methods. There's no fancy wrappers that will do it for you. At least that's what I believe the C guys would like the way to do it. Okay, and so original current working directory. So this was init git. It's called in main, which was in common main, and then we do command main argc argv definitions of command main. So show me the file name. I mean the file directory in this. Come on, IntelliJ. I mean, C line. You're so good. Why are you not like that? Why don't you show that? Okay. I'll put this here. These are all. Obviously, we don't need an OSS fuzz. Oh, this is fuzzy tests. Dang, nice. Helper unit test. Not need there, right? Git can have a daemon? Oh, for Git on the server. Okay. Git.c, which would be so git.c would be the actual git file command, right? Oh, bro, I am so stupid. I was confused, right? Why everything in entry.o, like all the o objects are there? It's because I ran make. I'm stupid. I realized it's because I looked at it and I saw git binary is already there. Wait a minute. Because I ran make. Stupid. So what this does is stir back init, string vector init, right? That's what it is. No, a single array should. I don't care, honestly. I'm not too curious about this. So if we don't have a command, we run git help. Otherwise, we figure out the command. So what this is doing is pretty obvious. Wait, I believe what it is doing is something like this, figuring out the last thing in there. Trace command performance. If a trace is not needed, don't do anything. And then do all the tracing thing. Tracing a whole different thing. I don't want to get into tracing too much because then that would take all the time. By the way, I'm gonna stop the video for a moment to make sure my stream doesn't lag. All right, so I've started the recording again. So let's have a look at this. So yeah, so where were we? We were looking at the trace thing, and we said we won't go there too much. Is the same as I never knew this either. Awesome. So we can do things like this. Get I'm not gonna do get in it here. So can I do this? No. Heh. Okay, whatever. So skip prefix, whatever. It's not very interesting stuff, right? We're just parsing things. After parsing, mm, mm, I'm recording, right? Yes, I'm recording. So where are we calling the actual function? We figure out the command and then we call that. Wait a minute. Mm, command skip prefix. Where are we actually calling the command? Okay, just some CLI stuff. Honestly, I'm not very curious about that. Okay, what? Where are we calling the actual command, bro? Bro, where are we calling the command? Are you kidding me? Are you kidding me? Handle built in? Okay, whatever. I don't care. Probably somehow we are calling the correct function that we need to call. And so let's have a look at those implementations. Although, no, I want to look at it. Dude, what the heck? Args, where are we passing the args with the command? I'm really sorry. I'm just not interested in this. I don't want to read this. Whatever, dude. Get out of my sight. So what does handle built-in does? Strip extensions, place built-in. So that's how we run the built-in. But then what's all the crap we're doing afterwards, right? After the handle built-in. Oh, okay, it was here. So run argv and then we just call handle built-in, which gets the built-in command based on this array, uh, this commands array. This is the commands array, and this is just an array between command string and the function pointer to the command. Every command is like this, and an option. So yeah, we have this. Okay, whatever. Obviously I was not gonna not be able to figure that out. I'm a genius among men. So these are all the commands, right? Let's have a look at some interesting commands like git commit. So this is the command commit, and this is probably in the built-in. It's not in the built-in. It is in the built-in. Bro, I'm not used to this new UI. I actually use the old UI of JetBrains IDEs, so it's a bit weird, but okay. So command commit takes argc, argv, prefix, and the repo because repo was already initialized. If you look at this in git.c, we call the commands here get built in. Uh, no, get built in, and then we call the built-in with the repository, and it was initialized in the function before the main.c here. uh, like you remember that, right? I'm not going there. Whatever, in common main here it was initialized here. So let's have a look at the command commit. Okay, if you're in case you're wondering why it's not like this, but I clearly said it should be like this, it's because it's probably not an interface for the library. Basically, if you are using it as a library, you probably don't get this command commit. Probably get it somehow in some other way. So let's have a look. Opt, quiet, opt, verbose. So depending on all these options, you do all these stuff. For example, if it is verbose, which checks based on the variable count up, honestly, again, this is just mess in my opinion. This what do we say, preprocessors macros, but okay. So we do this. What is n underscore? Okay, we marking it for translation, but do not translate it. Whatever. So we this all this ergonomic stuff. We want to look at the code, and there is the code. So stir buff. Actually, let's have a look at stir buff. What is stir buff, right? String buffer structure. It just has the buffer, the length, and the allocated length. Basically, how much length is in use and how much is actually allocated. So it's a string. Call it a stir buff. Just a string. Author identity, index file, reflog file, reflog file, not reflog. Object ID, commit list, chat, commit extra, pair repo settings. So I think this should be pretty obvious, like what we are doing, right? This should be pretty obvious. We are doing what we have said. basically we have to commit, right? So we see based on the options what we have to do, and then we do that. If it is from merge and all that, and it's all, so this is all domain stuff, right? This is how you define Git. If you're implementing it, you have to do this. I want to look at interesting pieces of code where from which we can learn something. So we might want to gloss over this once again though. So when we're committing, what are we doing? We get the get OID. So this is object ID. Wait, what? Okay, so we are filling. Okay, this is, I don't like this kind of I don't like this kind of arguments, but okay. So basically what we're doing is, this is an out parameter. This function fills in this object. This is the object. Now there's a lot of reasons why you would want to do that, right? Why you would want to pass this as an out parameter and get it filled. So the thing is, you control the allocation for this object. So if you want this to be present in a particular place in the memory, and I'll tell you why you might want to do that. For memory, first of all, memory management. Second of all, cache coherence, not coherence, but cache locality and all that. Okay, so probably why. But anyways, like the way I like functions in terms of purely how they are to read, if it was like this: repo get object ID, you pass in the repository, pass in the head, and then you have object. It should be like this in my opinion, but okay, that's fine. uh, this also helps C, I think, to return two values: one the error code, which is sent, and one the actual value. So many reasons like why this is so commonplace in C. So what we are doing, we're trying to get the head. Head is basically an object. So in Git, right? Actually, let me show you. So if you look at head, so this is awesome because I can just use Git to show you what it is. So you are in master branch. Head stores a reference to the master branch. If I were to go to another branch like main T, then head would also be there. Indexing, indexing. Okay, so look at this. Main T is here. Head is also there. If I were to go here, check out revision. If I go to this particular commit, a bit more after a hyphen RC0. If I go there, head is again there. So head tracks where you are. Okay. The way it does it is, if you go to git head, oh, yo, okay, it's not indexed. Anyways, let's first of all go to master because I don't wanna. We were in master initially, right? Or were we in main? No, we were in master. Okay. So inside git, let's actually have a look at dot git. I don't know why it's not showing this. Probably some IDE thing, bro. It is the okay. It's working correctly, right? Okay. I'm scared that it will start lagging and the video would be ruined. I don't want to record all this again, right? It won't be natural either. So let's go to git, and if you look at cat head. This is the contents of this file. So it's storing a reference to another object called master. Now this object is stored in this file. So what was that? Heads master, right? EDS. And now if you look at master, it stores the commit ID, the revision number. So if I were to check out to this, right, it's all and the same. Now I have to go a bit back and then do this. Then I'll be at the same place. I'm just not tracking it via the branch. So that's what a head is. Head is a reference object. Okay, it's a ref object. So what we're doing is we're getting the object ID for that. What is object ID? Object ID is just a hash, and probably stores the algo as well. So it's just the hash for that. So how do we get the object ID is we call with flags, then we create the context, which is unused. What is in context? The mode, the symlink path, and the path. We don't care. So we get the object with context one. Look at this name. Get object with context calls get object with context one. Now, many code bases would be like, oh, you want to call it helper, you want to call it internal, you want to call it delegate. There's so many ways to say this. Personally, I prefer internal, but I just as much prefer one. It's just so simple. And this can call one, and so on. I think I've seen such code in C++ standard library too. Oh, I can do what's in a code base of standard C++ library. That would be hell, bro. That would be hell. So the way we load get an object ID is this is the name of the object. Let's have a look. Get object ID 1. I love these names, man. I love these names. Oops. Peel onion. Basic. Where is that where I'm looking for? So this reminds me. So you look at this, right? There's so many branching um, to handle all the cases. So what another way, another very good way to understand a code base that I'm not really using because I've not set it up, but what you can do is you can call this function manually and use debugger to step through and see where the code takes you. That's another very good way to look at a code repository. I'm not using that because mama didn't raise no stupid person, but okay, whatever. So we get the object ID. If we are able to get it, then fine. Otherwise, we look up the commit or die. We parse the commit. Let's have a look at parse commit. This looks interesting to me. So this is the parse commit. Parse commit gently. Parse commit internal. Hey, we have all sort of naming convention here. So this calls. Before we look at parse commit, right? Where's gitbook? Gitbook. Okay. So a commit object. So this is what the object hierarchy looks like. A tree. Wait. No, it's not what I'm talking about. So let's go to chapters. Okay. No, it should be here only then. Yeah, so commit object looks like this. It has a tree. I'll tell you what tree object is. it has the author information, committer information, and then the commit name. Now what a tree is a folder. So when you look at a tree, it will be like this: the file, in the file inside it, the mode for that, like read, write, all that, the type of the file, the object ID of the file, and the name of the file. And then it can have trees within it. So a tree, the hash, the name. So this tree, this folder with this object ID has a folder back and two files. So this is what commit is. Commit just stores the tree ID, right? The tree ID of the root directory. So when we are parsing it, we are probably figuring out the tree and all that. So the commit should have tree. It may be null. I don't know why. Okay. So yeah, it has an object. So these are like the probably the common things every object has, whether it is parsed or not. What's the type? Type is basically just bad, none, commit, tree, blob, tag, ref, any, or all that, right? What are the flags? Flag widths. I don't know where the flags are, but I think they have mentioned all the flags here. So basically use the 28 bits, and let's say um, if these are filled, I think then it is it goes to revision.h. But anyways, these are the common things that every object has. Now they didn't use inheritance because that's stupid. You just compose objects from classes from other classes. We have a timestamp, we have a commit list of parents. So commit list is just a, wait a minute, what? Why can a commit has a commit list? Oh, probably. Oh, I'm stupid. Because it also has to have a parent. Every commit has a parent commit. If you look at this, let me show you. So this commit has a parent commit. This commit has a parent commit. Both of these, I think. I think that's what this is. Yes, I think that's what this means. Uh, yeah, I think that's what it should be. Then we have the tree, which is the the actual object that stores the hash for the current state of the entire repository, um, because it stores the hash of the uh, main directory. Now it is loaded if the commit is loaded from the commit graph file, then this member may be null. Only access it through the get commit tree. And then we have the index. So we are going to be filling this from uh, where is the question. So what we do is git does not support partial clones and include commits, whatever. What is this? Oh, paranoia. Awesome. Probably to help with thread races, if I had to guess. Oh no, they always had it, but they added a check to ignore checking whether they exist or not. So, hmm. So based on this object ID, right? This is the. Uh, Wait a minute, who called this? Uh, Gently. Okay, so this the repository should be able to load the commit. But which commit do you want to load? Have we already provided the uh, commit ID to this. Parse the commit, current head. Okay, yes. So this lookup commit is probably just filling the or maybe what this is doing, yeah, probably this is just filling the object ID, which should be this, yeah, this object information, right? The object ID and all these flags, and then when we call parse, we actually fill everything. I mean, that's what it should be, I think. um Obviously this is just an assertion, always good to have assertions, and you have to free. And free, so notice that they have to free on every return. Are they not free here? Yo, what the heck? No, maybe they're only freeing here they because object is not a commit, and so everything is gone to heck or whatever. What's this separately? I didn't know. Anyways, so parse commit buffer. So what this would do is, so first of all, the buffer, how did we get it, right? Oh no, this is a buffer. Okay, but how did we fill it? um, I don't get it. When did we fill this? uh, Show write only. Oh, this is a write operation. Huh? No way. No, it should be a read operation. Yeah, we are creating an object info and we are setting content p as buffer. Oh, probably we are filling OI. Yeah, so we read object info and we fill the buffer, which is the same as this. So we fill it here, read object info extended. This is the object info which is being filled here, object info, and then depending on the type, we okay, so we find the pack entry. So the way this is, I believe, I'm kind of forgetting how, like, what even a pack is in Git, but I think a pack, what is a pack? Oh, it's that. That's why I never used it. The pack just packs together multiple objects. So we get the pack entry. I mean, it was pretty obvious, but I just wanted to be sure. And find the pack entry. And then we get the info from the pack here. Info extended. So notice that no, yeah, packed object info. So this is if the pack is gone bad, I think. Yeah, mark bad pack object. Otherwise, if the pack was good, we get the object from the pack. We get the object offset, and the object offset was something we got from the pack entry. So from there, cache or unpack. Oh, sorry. Um, then filter. So pack files, I think we can explore separately. Well, because that would be interesting. So I think pack files, the aggregation point for objects, right, is pretty interesting to me. But yeah, we figure out the stuff from the pack, and then we fill it in the commit object, right? Now that we have the commit object, hmm, I forgot what index files were, so I'm gonna ignore them. But I think index file, maybe we can look at it. But now we prepare to commit based on the index file. Oh, probably index file is what stores what is staged and what's not. So using that, we prepare to commit. And I don't want to get into the reflogs, reflogs. Oh, maybe uh, git reflog action. Oh, so we can, I think, do something specific using the git reflog. We can specify something on git reflog, my message. Okay. So, anyways, uh, where are we? Yeah, so we're getting the commit tree here. And once we get the commit tree, we do all the unlinking, post commit cleanup. What is this? Rapport error. Okay. Okay, re. There's so much to unpack, honestly. But you might notice that it's no rocket science. It's just doing what it is supposed to do. Honestly, maybe I did not pick a very complex repository, or maybe it's just written in such a nice way. Because they could have for sure created a lot more abstractions and made it a lot more complicated to read, maybe with a bit lesser lines, but this is so much more readable. And you see this cleanup, right? So this is a common pattern they do in C. The way that works is you have a bunch of allocations, right? And you may want to get rid of all of them, no matter whether you failed or whether you succeeded. So every time you fail, you, instead of returning, you say go to cleanup. So instead of doing a return here, you say go to cleanup, and then you do all the free things, and then you return the actual thing. Now this may be null depending on if you failed or whether you actually came here, completely successfully completed everything. You do the release and then you return. So this was look at some procedural code, right? We looked at what commit does. It does what it does. Pretty obvious. Now let's look at some abstraction. And the abstraction I think we can look at for this video is packfiles, because that's what we glossed over. So very predictable, right? That it should be in packfile.h. That's what I like about this code base. It's so clean. It just has a lot of logic because that's the required logic, but it's pretty clean, very easy to read. Maybe even has a lot of repetitions, but doesn't matter. So this is the pack file. Okay, I'm thirsty. This bottle is leaking. All right. So pack get is the actual thing. I think I don't know what this data structure represents. They don't have much documentation here. So a pack entry is just a oh window. No, 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 no. Pack entry is in. Wait, do we have a struct pack file? What is packed? Oh, oh, okay. It's 2:19 a.m. I think I will be sleeping pretty soon. Get. So, I understand what packed is, right? But I think should have been like packed reader. It doesn't make too much sense. It should be pack reader, right? But anyway, so if you look at pack header, pack. So this is the header of the pack. Oh, let's have a look at pack.h. So we have a header, we have an index header, we have pack index entry. We should have the pack with the actual pack object. Uh, pack get one. Probably this is what it is. No man. So do they not represent a pack via like a composition of pack header, pack index options, and all that? It looks like that to me. Let's have a look at get pack. Eh? So fetch pack has these options. So yeah, it's not. They don't have an abstraction for a pack, which kind of ruins it for me. Honestly, I wanted to look at an abstraction. It is still an abstraction. It's a bit scattered, is what I'm saying. So do you want to look at another abstraction? Let's have a look at object abstraction. I'm really sorry, but it feels like I am running out of steam. So let's quickly look at object abstraction. So this is object, and then it goes on all the different kind of objects. This has all the parsing, but this really all there is. So we have already looked at commit to some extent. Let's have a look at uh, which one do I want to look at? Not commit. I want to look at bro. Let's look at blob. Right. So blob is very simple. It has only the object information. That's all it needs apparently. You can look up a blob. The implementation is like this. You look up an object and you create the object, because the blob is just file. So whatever you have read from the file, you just give that. So look up blob and parse blob buffer. I'm curious, where is the blob? I'm curious as to, are we never reading the blob anywhere? Object ID, look up object. which, wait a minute, I just want to have a look at object once again. Oh, here, look at this. Here they have that as the return type. Nice. Hmm, where's the actual data from the blob? So look up blob, we look up the object and we get this. Then object as type, okay. If it is, okay, this is casting. I want to look at where are we passing the data from blob. I mean, not passing, but at least reading. Pass just sets it to 1. I want to read it. I want to read it, man. Unpack object. Oh, write object should have it. Type buffer. Okay, so we have some free floating functions that are able to read or write an object, and because blob does not have any uh, parsing required, we don't have any extra buffer, so we don't have a pointer to the memory buffer. We get it through some other free function. Okay, actually it was too simple of an abstraction. Object object. Actually, I think the video has already gone too long. There's obviously a lot to look at. I really wanted to look at the allocation system, which was very simple. But I think I've looked at a pretty good chunk of it. Like we have looked at some procedures, some abstractions, some base level things like allocation and tracing. We didn't really look, but again, wasn't really needed. So because I'm running out of time, maybe I can make another video on this because I really like this code base. This code base is awesome. It's very neat, very simple, very easy to understand. Obviously, there's a lot of nuance. I've just glossed over it. It takes a lot of time and time in the field to actually understand what every line is doing. And I understand what every line is kind of doing, what it should be doing, but not really what it is doing to a very deep extent. Because only then you properly understand things. So obviously this was a cursory look, like I said, and it was pretty good. Overall, I would say this is a very nice code base to look at, and I would say it's a very good code base for beginners to start with. With that said, awesome work, Linus. Thank you very much. I'll see you guys next time.